Hi everyone. Um, Today I will talk about my project. The topic is real-time deep convolutional neural network and LSTM-based insider threat detection. Okay, as in the topic name insider threat detection, let me first talk about the insider threat. What is the insider threat? The insider threat is like, just imagine you have an organization and the attacker or an adversary is in your own organization. So you gotta find him or her or find them in your organization. But this topic is not widely focused by many researchers nowadays. However, this attack is a very important threat because the insiders know a lot of things in the company or organization. So, if they decide to be malicious, they can harm and can ruin your organization because they know a lot of things. They know the sensitive information of your organization. That is why we need to detect them and reject them from the company. So how do we do it? We have the things called insider threat detection, and we can detect the insider threat in two ways. The existing works use these two ways to detect the insider threat. The first way is the threat classifiers. In this way, we will talk about this way later. And the other way is anomaly detectors. Alright, it's anomaly, right? So we have learned about it. So it's like something that is anomaly or outliers of the from the dataset that will be assumed to be malicious. So first, let's talk about threat classifiers. So this way it uses the classifier to classify the actions. So they assume that the normal action is, oh no, sorry, it used to learn the difference between the normal actions and the malicious actions. So you just feed the input to the neural network or to the learning model, and then the model will output the probability that these actions are malicious. All right, this is a classification. But the problem is, in practice, we don't have a lot of data about the malicious actions. So it is the imbalance problem, imbalanced datasets, and it's very hard to classify the malicious actions. So it leads to the high false negative because it's like there's only a few actions which is malicious. So in practice, the classifier might might not detect the malicious actions, which causes false negative. But the solution is to augment the malicious actions so that we can have a lot of malicious actions in the dataset. Also, we can reduce the number of normal actions in the dataset to make the balanced dataset. Alright? But the advantage of this is it has a very high true negative because mostly they just output the negative class. So of course you're gonna have high true negative. Right? Another one is anomaly detector. This one assumes that the malicious actions are the outliers or are anomalies. because most of the action in the dataset are the normal one or benign one. But the problem of this one is that normal actions can be outliers or anomaly as well, because the human's behavior is not constant. You cannot predict. You cannot say that okay, this guy will do what you think, but he can do whatever he wants. So maybe some days he will just want to access the database, and some days he just want to send an email to his supervisor. It just depends on him. The pattern of his behavior depends on him. You cannot predict it, unpredictable. So this leads to high false positive, because whenever the detector detect the malicious the anomaly in the input, it's gonna alert high. It's gonna alert that there's a malicious action, which is false. It's just a behavior. It's just an unpredictable behavior of humans. And the advantage of this one is it has a high true positive, because it's gonna keep alert when something weird happens. So of course, when something really malicious actions happen, which is weird, it's gonna alert. So it's gonna have a high true positive. So my approach is that I'm going to combine the threat classifier and anomaly detector together. So I'm going to utilize their advantages, which is high true negative and high true positive. And I'm going to use this to detect malicious actions in real time, which means that whenever a user or an employee perform an action, the learning model will evaluate this action whether or not is malicious. Of course, we will use the past actions of that user as well to be considered. Okay, let's see the architecture of my approach. So first, the user here perform an action right here, and I'm going to do the feature extraction. I will say why we have to do it: to reduce the dimensions of the input, which I'm going to reduce from 10 features to 1 feature, and this feature will be collected to the feature database of this user. Alright, let's say user I. So this feature will be collected to the database of user I. Alright, and this feature also be sent to anomaly detection and to threat classification. So this threat classification will fetch the previous action of user I from user I's database. Alright, from user I database. Maybe M actions, let's say M actions here. And this will classify this bunch of actions whether or not it is a threat, an insider threat. And also this anomaly detection will evaluate this feature whether or not it is anomaly or it is weird, it is outlier in the dataset. If it is, it's gonna give the anomaly rate to the analyzer, and this analyzer will be fed with this threat rate from threat classification and anomaly rate from anomaly detection, and will wait between these two and decide whether or not it needs to alert to the monitor to take some action. Alright, this is my architecture. Okay, and let's talk about the dataset. So my dataset is from CMU Cert version R4.2, which is from Carnegie Mellon University. My dataset consists of the device table. This device table will tell like what user and when he or she connect or disconnect a device. Right? It can be like, for example, PC 1234, for example. For example, like Sarah connects to PC 1234 at 5 p.m. At November 30, 2020. This example, all right? And this email is a table of like the activity of the email. For example, Sarah sends an email to her supervisor at 5 p.m. November 30, 2020. Okay, and this file is like what file that users downloaded or uploaded. All right, for example, Bob downloads a file named example.exe at 5 p.m. November 30, 2020. All right, and this log on will tell who and when who log on or log off a device from a device and when. Okay, for example, Bob log on PC 1234 at 5 p.m. November 30, 2020. All right, and HTTP is about like to log like the connection via the internet. Like, okay, for example, Bob access the www.google.com at 5 p.m. November 30, 2020. All right. Okay, this 5 dataset is in this big dataset, and also it includes the attack dataset. All right, and this is in these 5 datasets as well, but this just with I think the owner of this dataset just pick it up from these 5 tables and create this attack dataset so that I can use it to learn the to train the classifier. I'll talk about it later. Okay, first let's talk about the pre-processing dataset, because I cannot directly use the dataset that I get, right? So first I am going to pre-process the device dataset. So I'm going to obtain these 2 features connected. So I'm going to perform the hot encoding to every table here, but just obtain some information from each table. I'm going to obtain the whole things because it's going to be a big one. So the connected and disconnected. Alright, if it's connected, this is going to be 1. If it's disconnected, this is going to be 1. Okay, as well as email. If an employee sent an email to the inside email, this is going to be 1. But if he or she sent an email to the outside, to the external email, this is going to be 1 instead. All right. Similarly, file table. So if, because let me say this. If mostly the malicious file is in the exe form, so that the user can directly run it, easily run it. Okay, so if the file's extension is exe, it's going to be 1, but if not, this is going to be 1. Okay, And for the log on, if it's log on this one, if it's log off this one. But I don't use HTTP because the data is too large. It's 14 gigabytes. I cannot like um, I cannot even define this variable with 14 gigabytes. I might need something bigger, has a bigger CPU. So I will focus on these 4 datasets instead. And in total, my dataset has the following fields right here. So first I have a date, I have a user, and this is a frequent PC, which is this is one when there's some activities with the most usage PC for a specific user. But this one when he or she use another PC, which is not usually used by that user. And these 8 features is just from this hot encoding. Okay, but I just when I use it, I will just use these 10 features because this is just to tell that okay, this data is owned by this user with this date. Okay, let's talk about the attack dataset. So the attack scenarios which are also in the normal dataset are also provided, but there are not a lot of them. There's just a few of them. And this attack dataset will be used to train the classifier, and also I use it to check if an action is malicious, to learn and test by the anomaly detector. Okay. And for the feature, okay, I just put here just to remind you about my architecture. So first, I'm going to talk about feature extraction. Feature extractor, I use the auto encoder to perform feature extractor. So this is going to be 10 features, and this is going to be 10 features. So as you know, I'm going to learn until the reconstruction loss is stable. Alright, and I'm going to use this one feature here for threat classification and anomaly detection. For the threat classifier, I use the one dimension convolutional network because the data is special so that the classifier can learn the pattern of the malicious action. Because the position of the data is matter, that's why I decided to use a one-dimension convolutional network. And to train the classifier, I just need to augment the malicious sequence of actions. So I pick the sequence of the normal action, and then I learn it that okay, this is a sequence of normal action, and train it. And then I pick the sequence of malicious actions from the attack dataset and also the augmented one. Alright, so how do I augment it? So I just put some normal behavior, so normal actions between them, or just on top of them, or just on the tail of them, and then use it to train the model, the classifier, that okay, these are malicious actions. Alright, this is how I train it. And let's talk about anomaly detector. For this one, this is to detect anomaly, and we assume that anomaly is malicious. Alright, because this data is temporal, it changes in time, and the information needs to come in sequence. So I decided to use LSTM, long short-term memory, because it is a recurrent neural network, right? And it's good for the sequence information. because it can memorize the data, the past data, which is which fits this goal. So each user has his or her own LSTM auto encoder. So anomaly score varies the reconstruction loss. So I'm going to train the normal dataset in the LSTM network in an LSTM in auto encoder. So if the anomalous input come to this LSTM, because we don't train it a lot, because there's only a few of them, which means that the output will not like match with the input, so there will be a lot of loss for anomaly, which is assumed that it is malicious. Okay, so I have this in this example I have n users. All right, so this gonna check, okay, which user. So for example, user 2 go here, user 1 go here, user n go here. Okay, and the train is very simple. Just train it. Just use the normal dataset to train it. And the loss is the reconstruction loss. So my progress is here. I'm working on evaluation part. So I'm coding the architecture, the neural network for my classifier and anomaly detector right now. So I think I'm going to finish this in 1 or 2 days, and then I'm going to write the report. So for the conclusion, so the classifier can cause a lot of false negative, and anomaly detector can cause a lot of false positive. So, and then I apply the hot encoding method to the dataset CMU cert R4.2. And autoencoder is applied for the data extraction, which is dimensionality reduction. And because the sequence of actions is special, it has a pattern for the malicious actions. So I use a deep convolutional neural network for the threat classifier, and also I use the LSTM autoencoder for the anomaly detectors. And I use the results from those two to be analyzed in the analyzer and decide whether or not it needs to alarm to the monitor to check on this user. Okay, so if you have any question, you can comment below. Thank you.